All right, we're right where we ended yesterday there, Allie girl. Sorry you're not with us. And at the very end, we did some review. We didn't record that for you, but kind of starting where we ended yesterday, we were looking at a kind of operation or combination. We weren't just multiplying or just adding. We were doing both. Can you find what I called that? Look on your notes and tell me what I called that when I did both. So I can't say I added, I can't say I multiplied. I have both things going on. Did you write it down right before we left? So I say I added A, and I multiplied, say, by B, and I went like that, A plus BX. Do you have a name for me? Anyone write it down? All right, we'll add that to your note section there from yesterday, and that is called a linear transformation. That's where you're doing both adding and multiplying. So we have to do the little baby in the bath water, but don't throw the baby out with the bath water. See it on the back there? We're going to do that problem to help us with the linear transformation. Allie girl, you still have that paper, so we don't have to shine a light on it for you. In that, we have these little tubs. Could this really be true? That you have a setting on it, and it'll take the water and make the temperature of the water what you set it on. Could it be? All right, so you buy your baby, so you can put cold water in there. You buy your baby a tub. Oh, yeah. You buy your baby this tub. It has a setting on it, and it will warm or to cool the water to keep it at a right temperature. So you're not scalding or freezing your baby. So, such things in the world. In our day, we just put our finger in. Imagine that, you know? So, but you're not going to get along with that one in the next generation. So, it turns out that we have this tub setting, and X is our random variable, and it's going to represent the water temperature in Celsius. So take a note around that picture there. Water temperature in Celsius. Water temperature in Celsius. That's what our random variable is. And when they already calculated the mean for us, so it turns out if you set it on a certain setting, the mean temperature, well, I know, it's a safe, they have a setting on the tub, it's safe for babies or child safe. And the mean of that setting is 34 degrees Celsius. Looks cold, but in Celsius, that's nice. 34 degrees. And the standard deviation is 2 degrees. All right, so again, these are both in the Celsius. And now I want to transform that so I don't think in Celsius very well. I want Y to be the random variable, the water temperature in Fahrenheit. I don't know how to spell Fahrenheit. German. Is that spelled right? It's close. It's close anyway.
I don't think it's H-O-R.
Okay.
It is. It is.
Oh, it is.
No,
You're
I
tricking
didn't.
me. You're tricking me. All right.
Never.
So,
That's right.
anybody timing this? I guess we've got about, what, 3 minutes or 5, 3 maybe?
Sure.
Sure? Okay.
It's been.
Barely stole my concept of time.
All right, we'll just go 10 minutes from now. It shouldn't be
It's your
over.
fault.
All right, there you go. So, water temperature in Fahrenheit can be transformed because we know Fahrenheit takes 9/5 times Celsius and adds 32. You have to get that from the scientist or the mathematician. And knowing that, we can do this problem. The question is, find the mean value of the new random variable y. So what we can do is look at the transformation. To go from Celsius to Fahrenheit, we have to multiply by this number and add this number. So, looking back at how we were trained of what happens to the mean when you add and when you multiply, can you not see how to do it? See if you can come up with the new mean, taking the old mean, and involving this transformation. So, find the new mean. Do you have it? All right. See if you know what to do. I haven't told you yet. Let's give it a try.
We had to do this in our
Yeah, we
homework.
did this in the homework already.
Okay.
Because
Same
I think-
exact
I
numbers?
think it was the same numbers. I didn't.
Was it the same? I think it was different.
I think it was a different problem.
But the same idea.
Yeah, it was the same
Yeah,
idea
so
though.
good. That's good. We won't have to do that one together. Because I was going to ask for homework questions right after this.
93.2?
All right, so did you take 9/5 and multiply it by the old mean and add the 32 because of this principle? Add, multiply. Even though we put them together, we're still going to take the mean and multiply it and add it. Add the transformations. So 34 times 9.9/5 plus 32, 93.2. All right, so that's the new mean. That's the mean in Fahrenheit. Does that sound like it's too warm, 93.2?
I don't know what temperature my bath water is usually.
98.6 is our body
Yeah, so you
temperature,
don't
so
really
I
tricky
think
about
just
that.
below it would feel pretty good. All right, let's look
I feel like I
at
like when it's
the
hotter
standard.
than
This is
that.
where
Yeah.
this is where your understanding
for a
meets the
baby.
road. The rubber of your understanding meets the road.
Maybe
Is the standard deviation going to be calculated similarly? Are we just going to take the 2 and put it in the formula?
You're not gonna add the 32.
Very
but you are
good.
gonna multiply.
Right, because of ding, 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 ding. Remember, when you add, it does not affect the standard deviation. So when we added the 32, that's not going to affect anything, but the 9/5 is. So Julia, what do you get when you do 9/5 times 2?
3.6.
Right. So note the difference between finding the mean is kind of what you would expect. You would just throw it in the formula, but the standard deviation is not affected by this plus 32 because of our previous discussion. There is one on the homework like that, so make sure that you have done it correctly. Look back on it now
Do you
and
remember
see.
which number it was?
We can look. You should be able to tell. All right. We should be able to tell. And I'll take other homework questions now. So, Caleb, we have to turn off the video so we're not wasting time, wasting it, but not using up too much video time.
Bye.
We'll be back.